In this Boron New and Improved video, I'm going to talk to you a little bit about boron and show you how I make elemental boron from roach killer. This is a adaptation of Mr. Home Scientist's method, and I give credit for the original idea to him. Boron is used in borosilicate glass. Borosilicate glass is a special kind of glass, sometimes known as Pyrex, which does not expand or contract very much when heated or cooled, and therefore won't crack if you heat it in an open flame. Lots of good labware that I have is actually made out of borosilicate glass, and it's really nice because I can put it directly on an alcohol burner or propane torch and it will not crack. Another application of boron is in boron nitride. Boron nitride is an extremely hard crystal. It has one form that's been created, which is only just slightly less hard than diamond, and another form that's been theorized to exist, and that would be slightly harder than diamond. So there theoretically is a substance that's actually harder than diamond. What's nice about the substance that's even less hard than diamond is that it's much cheaper than diamond, and therefore can be used for various industrial purposes. Many boron compounds are quite flammable and can be used as for pyrotechnics. In fireworks, it's really nice because boron's emission spectrum is a really beautiful green color. At one point, boron compounds were considered for being used as rocket fuel. Another thing about many of these organoboron compounds is that they're quite toxic, so you really don't want to mess around too much with them. I may post a video later on with me detonating some borane gas, but don't hold your breath for that one. As you may have noticed, I do these videos cold, and last time I uploaded the boron video, I actually forgot a pretty important use for boron. This use is in borax laundry powder. Borax is actually sodium tetraborate, and the tetraborate part means that there's lots of oxygen in the anion. What that means is that at high temperatures, it can actually give water an extra oxygen atom, turning water into, or H2O, into H2O2, or hydrogen peroxide. Hydrogen peroxide is a bleaching agent and, in general, a cleaning agent. So that is how borax actually helps you clean clothes. Alright, let's go down to the lab and I'll show you how to make elemental boron from boric acid. Hello. Here is the first step to making elemental boron. You can start with boric acid powder, which is a white powder. You can get it as an ant or roach killer. Here's what I got. Kills roaches, boric acid. The next thing we want to do is convert boric acid to boron oxide. Boric acid actually has a boron atom surrounded by 3 OH groups. When heated, some of those OH groups will actually form H2O, leaving behind an excess of oxygen, and you will see some water vapor actually coming off the white powder. I'll be left with boron oxide. Some people say boric oxide, some people say boron oxide. I got a bit impatient with my alcohol lamp, so this should speed things up. I moved back to my alcohol lamp, and you can see now that a good bit of the original white powder is gone, in fact almost all of it, and in place of it is this some crystals and this gooey, thick, brownish liquid, which is liquid boric oxide. The next step, now that most of the boric acid is gone, is to remove that pesky oxygen from the boron atom. The way we do that is by mixing the boric oxide with a more active metal, in this case magnesium, heating them up, and the more active metal, although boron is a metalloid, not a true metal, the more active metal will take away the oxygen, will steal the oxygen from the boron, making magnesium oxide and elemental boron. I thought to do Mr. Home Scientist's method, which is to grind up the boron oxide, grind up magnesium powder, well, start with magnesium powder, mix them together in stoichiometric ratio, and do a thermite. But I didn't want to spend a lot of work grinding this up, because it's a lot of work to grind this up. So what I thought of doing instead is I measured out the stoichiometric amount of magnesium powder, and I had a little bit of extra diboron trioxide, which I have in there, but it's a very small amount, and it's stoichiometrically correct, plus a little bit extra that I'll add for ignition. But basically, I'm going to just melt this, and then pour this into the molten mixture, and mix it up. And then I'm going to stick a fuse, like a normal fireworks fuse, directly into the molten mixture, so that hopefully I don't have any ignition issues. We'll see how that works out. Alright, here you can see my makeshift crucible filled with magnesium powder and molten dibarium trioxide. And I'm going to stick a fuse in there, light it, hope that works. Otherwise, I'll use my potassium permanganate glycerin ignition method. So let's see how this works. Alright, here is me adding the potassium permanganate, part of the ignition. There's the glycerin, and it takes a little while to get going. And now I cover up the beaker so that oxygen doesn't get in, so that the boron doesn't reoxidize. And that should be a good amount of elemental boron, some magnesium oxide, a little bit of magnesium boride, and yeah. Okay, so here is the cooled down slag. It's still actually quite warm to the touch, but compared to how hot it was earlier, quite cool. And what I'm going to do now is add hydrochloric acid, which will react and form soluble compounds with everything except for the boron itself. And I'm going to be, unlike Mr. Home Scientist, going to be adding the HCl directly, because I previously did a small-scale test to show that there was no diboron formed. And anyway, I've got a fan off screen that's sucking everything away. So I'm going to just keep adding HCl until no more bubbling occurs. After experimenting with different ways of getting rid of all the water and HCl, dissociated HCl that's in the boron, and getting some boron oxide in the process, torching it, all that kind of stuff, I finally decided just to put it in a desiccator bag, a homemade desiccator bag, and I think this is probably going to end up being the best method for getting rid of the water. This is the boron, and then right here I've got a small beaker full of sodium hydroxide, or lye, which is extremely hygroscopic. It'll actually absorb enough water from at least ordinary water vapor level air to it'll absorb enough water to dissolve itself. So I'll wait a few days and see how it works.